Well, can you believe it? We actually have an Easter Sunday stream. I can't believe it. My voice is back, which is nice. Just wanted to welcome you all here, and I wanted to also welcome Daryl Mason. Hi, Daryl. How's it going?
Hello, Mark. I'm good, thank you. Happy Easter, and hello, everybody.
Happy Easter to you too, Daryl.
Oh yeah,
Did you have a good meal today?
I did. I always do an Easter meal, classic ham, scalloped potatoes. Asparagus was a vegetable this year.
Oh.
I even remembered to make deviled eggs, but then I forgot they were in the fridge when I plated up the meal, so I
Oh,
didn't eat it.
boy. Oh, no.
I'll have twice as many tomorrow.
Oh, boy. Well, you know what? It's okay. You'll have twice as many tomorrow, like you say.
Yep.
Welcome, everybody. Welcome here on this Easter Sunday. It is April 9th of 2023, and it is April. Can you believe it? We are looking to get out of winter already and heading into spring. But we still have some winter sights tonight, and we're going to see a few things before the moon comes up, and that's going to be fun. Okay, so I want to say hello to Marcin Johansson, who is here. So nice to see you. We have Cyclone Michael Hendrick. We have Bonnie on Hada 77, Robin Curtis, Terry Haig, Ronald, ERT Radio. Hi there, Ronald. Good to see you. Elisha Vieras, how are you? And let's see who else has joined us. Izabela is here. Hello, Izabela. Thank you for coming in and saying hello to us. And we have Rascally Rabbit is with us tonight. Nice to see you, Rascally. Judy M is here, and I think we have Cindy Murphy as well has joined us. Thank you, Cindy. Good to see you as well. I want to make sure that people know who our patrons are. These are the people that have done very well for us to help us out. We have John P, Isabella M, Ollie B, Chief McCyber, Vera C, Ronald T, Martin W, Raymond B, Cindy M, and Terry H. We want to see that list grow, so if anybody wants to contribute to us and subscribe, you get stuff for it. It's not just subscribe and give us money, it's subscribe and you get something for it. And we're spending a lot of time processing photos. Isabella's doing that, I'm doing that, and we'll make those available to you when you join our Patreon, the fully processed shots. Anyway, I think you have to join the $10 level to start getting shots. Anyway, this is the star Sirius right now in the view. We're looking at this, and we're going to actually do a focusing test. But first, I have to bring us up to speed, and that means getting our system exposed correctly. So we're going to 1 second exposure at 250 tonight to begin with, and then let's go into night vision mode. And as you can see, the stars are out of focus, which is intentional. So now what you'll do is you'll see us make the focusing arrangements. Okay, we're gonna run the focus inward, and we're gonna build a focus curve, and that focus curve will appear right here. It'll dip down and then it'll go up, and at the center of that focus curve, it will be a fully perfectly focused stellar image. Hello, Renee Cruz. Yeah, we have a great family here, Ronald. Jose Santos, how are you? Thank you for wishing us a happy Easter. Happy Easter to you as well. Okay, so we're focusing up here. We're selecting a star, and then we run it through a focus test and check it against the size. And if the angular size is nice and small, it means that the star is focused, and that's what we're doing. We're trying to get it focused. So we'll let that run through. I had a good Easter as well. It was nice. Went to my sister's house, and they sat there and fell asleep watching the golf tournament. It's like, whatever, okay. I can't hit a ball and go chase it. I don't know. I mean, I used to play golf, but it just wasn't too exciting, you know.
Mark Twain said, "Golf is a good walk wasted."
That's a very good thing to say. It is a good walk wasted. Yeah.
I worked on a couple of golf courses a very long time ago, and
Yeah.
I thank you. I have no desire to play golf.
Yeah. All right, we're gonna go to this best focus curve and see just how good it did. It looks like it wasn't perfect, but let's see what we got. All right, now let's get rid of it and come back and zoom in and see what it looks like. Let's see. Looks really good. And we're looking at the brightest star in the sky. That's Sirius. Sirius. Yeah. And Sirius is an amazing star.
That reminds me, I saw Mercury again tonight.
You did?
Yep, saw it the night before last and saw it again tonight. And
Wow.
he comes and goes really quick. He's going to be highest on April 11th, and then he's going to drop like a rock into the sunset again.
Indeed.
If you look below Venus and a little bit to the right, maybe half an hour after sunset, he'll go away pretty quick.
Okay.
But you'll see a semi-bright star-looking thing about a hand and a half below Venus, and that's planet Mercury.
Wow. Well, from here, right now, tonight, we're going to go to our first object, and that's going to be Thor's helmet, which I really like because Thor's helmet is a phenomenal object to look at. You see our streaks going on there. That's the telescope zipping off to the Thor's helmet region, and there is Thor's helmet. In our night vision, you can see, and it's centered up nicely, and this is fantastic. So for people to understand, I have this is the live observatory broadcast is on one screen, and then I have the broadcast software that is giving me the chat and the music and Daryl's voice levels and all the other little goodies on the right hand side. So we will tend to use that. So you'll see my head going back and forth. All right, but I'm really talking to this right here, this screen that you see right there. All right. Okay, so we are guiding now. This is our guider up there. You can see. I've shown you this before. Most of you know that. Look, we had a Starlink to zip through. All right. This is 1 second exposures. And let's go see what a 40-second exposure will do with Thor's helmet. All right. So here we go. So we're going to get out of the night vision mode and go into our live stack. This is where we take an image, take a second image, align them, stack them, and make an image sandwich. And so anything faint will actually come through as a more pronounced data over time. Even the dark nebula, that's most important. Dark stuff will show up very brightly, which is how come we can see them so well. You know, and you might want to, like I said, consider joining our Patreon. Okay, we actually have a number of tiers you can join, from $5 all the way to $200. Okay, but the reason that and that's monthly, and why would anyone do that? Because of what we give you. Okay, now right now it doesn't look like much here. Okay, but we have to do some processing, and there we go. We did some processing, and then we color correct, and we did the first image, and as you can see, it's got some noise. It doesn't look all that exciting, so we're going to make it exciting here in just a minute. All right, so here we go.
May I ask a question?
Of course.
Folks, can you hear me okay?
Yeah, they can hear you. You're going out at my level, exactly, almost my level.
Okay. You're dropping out a little bit again. Maybe you're just moving away from the microphone.
Whatever it is, I'm watching my level, so it seems like we're doing okay. But I will
very good
defer to the other people. Hello, Curtis Horn. Good to see you. Genghis is here. All right. So let's I'll do one thing here. There we go. All right. We'll pull this down.
Thank you, Bonnie.
What'd she say?
You sound great, Daryl.
Well, that's good.
Cindy says we both sound great.
Fantastic. Thank you, Cindy.
Thank you, Cindy.
Let's bring this over.
It might hit 80 degrees here Tuesday and Wednesday.
Yeah, that's projected for us as well.
Springtime in the Rockies.
Yeah.
And then they're saying it might snow again Friday.
Wow.
That's more like springtime in the Rockies.
I guess it is from what you've been telling us.
80 degrees is unusual in April.
Uh-huh.
Here.
So Thor's helmet is a very interesting location in the night sky. Very interesting object. Obviously, there's many stars that you see here. But what's going on inside of Thor's helmet is fantastical. It's just, okay, first of all, you see these bubbles. And these bubbles are being blown by a very hot star that is literally separating the outer envelope of the star and pushing it away from the core of the star. And that's what we're looking at right here. And you can see the wisps in this, the way this is rendered right now. But let's pull that back a little bit so you can see a little bit more detail here. As we pull it back, look at those wisps. They're very complex. Very complex. All right. And, okay, so now, if we pull this in, we'll try to extract some more detail. I don't know why it's doing that. Okay, let's do this. All right. You can see there's a lot of detail out here going on. Let me just make this a modification. See all these pieces out here, and you see this reddish area. That star right there, okay? And for those that need to see the exact star, it is the one inside this red square, okay? That star right there in that red square is what's called a Wolf-Rayet star. Wolf-Rayet, R-A-Y-E-T. And Wolf-Rayet stars are well known for being extremely hot and extremely powerful with their stellar winds. And these powerful stellar winds will push that material out for reasons that nobody can really explain very well yet. And this green is ionized oxygen that has been blown off of the star. Now keep in mind, you say, well, oxygen, that's pretty cool that there's so much oxygen in the universe. In fact, oxygen is the third most abundant element in the entire universe. Did you know that? It's not just hydrogen and helium like we know happens. It's also hydrogen is the most populous. Then we have the helium, and then we have oxygen, and then followed by carbon. So it stands to reason that if there's going to be life in a universe, it's probably going to be based on carbon. And that's kind of what we're seeing. So it's pretty neat that we see this green glow from a nebula. And that green glow, of course, is from ionized oxygen, because there's so much of it in a star's atmosphere when they're made, and possibly when the star makes oxygen in its core. The red is hydrogen gas, and possibly some other elements as well. But the hydrogen gas will tend to make a very powerful red color that we see fairly often. So that's what we're looking at here. We're looking at oxygen and hydrogen ionization.
Yep. This might remind you of a planetary nebula. It's not really. You might think of it like a planetary nebula on steroids. Planetary nebulas, their host stars are white dwarfs, or on the way to being white dwarfs, and the Wolf-Rayet star here, it's on its way to being a supernova. So it's much more, analogous processes, you might say. Mark, shoot me down if you think I'm wrong, but it's sort of analogous to planetary nebula, but much, much more powerful. And the end result is going to be a supernova instead of a white dwarf.
And he's right about that. And what might end up in the center of the nebula, where that star is, will be either a neutron star or a black hole. Now here's a quiz for you. If the sun became a black hole right now, of course we wouldn't know about it for 8 minutes, of course, because that's how long it takes light to get here. But what would happen to all of you listening? What would happen to the Earth? Now, besides the fact that it would get very cold and we'd eventually, die from cold, would the planets spiral in to the black hole? If the sun would, now the sun is too low in mass to become a black hole, but would all the planets suddenly spiral in? And the answer, sometimes the answers defy potential logic, but the answer is that the planets would just continue to go around the sun as normal. The only way that it would ever be that the planets would spiral into the sun is if the sun became amazingly more massive, and it can't. And it's sort of a trick question, because the sun is too low in mass to become a black hole, for one thing. But again, if the sun were to become a black hole somehow magically, and you could set a trigger and have it just go to become a black hole, boom, at its current mass. If somehow you could do that, then the planets would just continue to circle the sun just like they do now, because the gravity doesn't change. But if it's a more massive star, then, if anything, the gravity of the black hole that's made is going to be less than the original star, because the original star might be 20 solar masses or so, but the black hole might only be about 5 at the end, or maybe 10 or 6, all right? So that's interesting, the way that works. That's looking pretty, and it's got some nice additional coloring going on there.
Michael Hedrick asked, at what distance does deep space begin? I suppose that could depend on your definition, or if there really is a hard set definition to it.
Well, as far as the definitions we understand, we would say interstellar space, which is synonymous with deep space, I think. Interstellar space begins at the heliopause, the place where interstellar winds from stars outside of our solar system come up against the sun's stellar wind and sort of balances it. Okay, and so it's just sort of, they don't push one away from the other, they just sort of balance and ride along each other for the period of time that the stars are all going by themselves at this point in history and time. So where the heliopause begins, I think that's what we would call, quote unquote, deep space or true interstellar space. The influence of the sun is no longer a factor.
Right.
That's where Voyagers are right now. Ronald says Andromeda would be deep space. Well, between here and Andromeda would be intergalactic space, and that's the same as deep space or interstellar space, effectively. Just the star chunks, the star clusters are far away from each other. One's the Andromeda Galaxy, one's the Milky Way. And if you're in between, you might actually find that there's some interesting stuff going on in between. Because our Milky Way is got some rather interesting material hanging out outside of it. And in between galaxies, we see it as well. Lots of interstellar gas in between galaxies, long drifting clouds of interstellar gas, atoms that are just out there. Pretty interesting stuff out there. I don't want to be there.
Might depend on your point of view also. I mean, a planetary scientist might say something different than a cosmologist would. Cosmologists tend to think in billions of light years.
Yes.
So that's deep space to them.
Absolutely. I just put on an enhancement so you could see in the detail in here. You can see it. And we're at 40 seconds and a gain of 250. Now, just for the record, so you remember, the two most important parameters are this one here, the exposure, and this one here, the gain. These two parameters are the most important ones. This tells us the sensitivity of the chip, and this tells us how long that chip is going to be exposed for. All right, so that's what we're seeing there.
Could you go to 300 yet?
I will, but I don't want to do it in the middle of an exposure.
Right.
I could, but it can alter some of the upper values. I don't want to do that.
No, the moon rises at 11:02 Arizona time tonight.
Yes, thank you. And that's
at the observatory. So.
Right. So we're at 8 o'clock out there right now. So we've got a couple hours. We got some time to play here.
Sky might not even be completely dark yet either.
Yeah, I think that's why we're getting some little red glow in here. We're seeing a little bit of the sunset, and I got to correct to make it so you can see it like that. So what I'll do is I'm going to pause this right now. This looks nice. And Curtis said something I wanted to respond to here in just a second. He says, Curtis said, I thought it was where the solar radiation basically stops being dominant. Yeah, that's where the solar radiation is no longer effective. It's the same thing we were saying. It's where interstellar winds from stars more distant kind of balance and no longer can thwart that stellar wind. It's sort of like the mixing spot, right? Sort of that sweet spot. And it's got a weird shape to it. It's not perfectly round around the sun. It has a lot of dependencies. Okay, so let's save this here. That's really pretty. And let's save it exactly as seen. Excellent. And make sure that we should be saving it as a 16-bit. Right, good. It did already. Nice. Okay. So there we are. So if I say resume, we did 19, so I'll just go straight to 20 and then leave it at that. This is good. Michael Hedrick says, Mark, if we had a visit from aliens, what point between Moon and Earth would we defend or defend the whole solar system? Well, we don't have the capability even to defend our planet, so never mind between Earth and Moon. But well, let's be hypothetical. I suspect that we would probably find ourselves in a situation where we don't know exactly where they are. I have some ideas. I tend to think actually that any alien beings, if they're here, are probably going to be underwater. Why?
I knew you were going to say that.
Yeah, I've said it enough, I think, huh? And the reason is pretty clear. Let me first save this again and save it exactly as seen. The reason's pretty clear because if they go to the moon, well, they know we have coverage of the moon. We know the moon left and right. And by the way, the Lunar Reconnaissance Orbiter Quick Map, the LROC Quick Map, if you look that up, you can survey the moon, every square inch of the moon, and go enjoy checking it out. And guess what? There's one for Mars now. Haha. Yeah. And so you can go through Valles Marineris right down at the ground level and go zipping through it. It's just beautiful. I know you want to know where it is. Where is it? Well, let's see. Let me just put up the link for you just so you can see it. So just give me a sec here, right here. It's called the Murray Lab, and I will bring it up, and I'm going to post the link. This is the link to go and to look at Mars in the same way that we look, the way we look at things. Let me just go here. Okay. All right, okay. just
a link I can post?
Yes, I'm about to do it. I'm about to put the link up. So just give me 1 second. Just a second, guys. All right, here comes the link. Yes, Lubo, this is Thor's helmet. Very good. Thank you for noticing. Okay, here's the link to the Murray Labs Mars mosaic. Okay, there's a lot that you can do in there. It's pretty cool. All right.
Thank you. I probably already have this, but
Yeah, no, it's really nice.
Yeah.
Now, Mars is in black and white on this, but that's okay. That's okay. All right, so now let's clear this and go back to our, we're going to go back to our night vision mode here. Okay, and as you can see, you can just barely see it, huh? Notice the green's a little darker because the sun is setting more, and it makes, our initial images are going to be just a little noisy until the sun gets lower in the sky. All right.
yeah, you're not even at astronomical twilight there yet.
I know it, but see what we can do? We can actually counteract it. Let's love it.
Yeah.
So while we're here, let's go take a look. I want to go here. Go ahead.
8:24 local time, I believe.
Yeah.
It's only 8:01 out there now.
Yep. So we're going to try out Dreyer's Nebula, which is right near the Christmas tree cluster. You'll notice the telescope is moving. And of course, you can't miss it. So we're in the west right now. There it is. And we're going to move that to about here. And then we will be able to start exposing once we get set. So here's what we're going to do. We're now going to go to the east with the telescope. Move it to the east a little bit. I don't want to jinx things, but our internet connection is pretty darn good right now. Okay, I think this is about right for this. Okay. Yeah, we're searching for our guide star. Go ahead.
Speaking of Starlink, anybody excited for the evidently they're going to launch the Starship Super Heavy soon. Like they were saying the 10th, and now they're saying the 17th. So a week from tomorrow.
Yeah, I am. I'm excited. I'm looking forward to see what they're gonna be able to do with it. I know they want to go to the moon with it.
The first mission they're gonna the booster's gonna drop off into the Atlantic, and I don't think they're gonna recover it. And then the Starship is supposed to drop into the Pacific out by Hawaii.
Okay. Hey, Master Player. Welcome. Thanks for coming on. Okay. Let's see. Lubo says, considering so many newly discovered nebula, will you join the train and want to discover something new too? Yes. As a matter of fact, Lubo, we've already captured a meteor striking the moon, but we take pictures of the same thing fairly often, as you notice, and we take pictures over a course of several years. So all of that data is available to you. So you can also go out and discover something new, because you can take our images of the same object from a year ago and compare them to today and see if something new has happened in the intervening year. I think that's pretty cool. All right,
James,
so now
I do not know. Should be interesting to watch.
What's James asking?
Are they going to try to land in the water upright, Daryl?
Oh.
Maybe. I mean, that's the objective. Will it work or not? Who knows?
Yeah, I don't know.
This seems like a pretty big jump from the ground landings they finally achieved with the smaller starships before.
Agreed. Okay, this is This is going to be a 40-second exposure. This little nebula over here, there's dark nebula associated with this stuff over here. And dark nebula is where it's at. You'll notice there's sort of a reddish glow over here. Well, keep an eye on that, because that's important too. So let's get out of night vision mode and go into a stack again. And remind people of what we saw last time. We saw Thor's helmet. Okay, so this is up there now, ready to be perused, just like this. I have the picture just like you see it available. And now we'll clear this in light of our next exposure of Dreyer's Nebula.
You know, you mentioned us seeing a meteor hit the moon.
Yeah.
There was another one that happened recently. It was recorded in Japan.
I saw it. You're right.
Yeah,
It was
a meteor
great.
hit the moon.
It was
Asteroid,
wonderful.
whatever you want to call it.
Yeah. Okay, let's pass this here and all right, let me. Oh, I think I stopped at the wrong point. I did. I need to go lower. Well, yeah, I need to go lower. Okay. My mistake. Let's get it set up again.
Lubo, James, if there's one thing that Elon Musk is a showman. And I'm sure he wants to put on a bit of a spectacle, and seeing that thing land vertically, even if it sinks in the water, will be a heck of a view.
I think he just likes to have fun too.
Oh yeah.
He's very much into doing things that are just cool, which is neat. Okay, so we're coming up here. I see the nebula here. So I'm going to then move a little to the west so we capture the blue part of the nebula more. I think that should be good. Yeah, because that's where we're going to be. Okay. Hey, Starlink. All right. So let's actually pull us up a little more. All right. And go a little bit to the west again. One more jog. Okay. And so what you see over here, right above me, you see the telescope in the building, but then right here, it's searching for a guide star among all these. It takes 14 seconds to find a guide star, and when it does that, and it begins to show us what we need to see. Now I can see, actually, that we just have to... I gotta pull this
Marianne
out.
is here. Hello, Marianne.
Marianne, hi.
Mark, Master Player makes a good point. You might want to change the title of the stream if it's not too late.
It's certainly not too late. Did I make a... I knew I forgot something.
You know, it says ignore or test something.
Okay. Yeah, don't ignore it. Not a test. Let me edit this. All right. Thank you, Master. Hello, Marianne.
What is it now?
Now it's beautiful evening nebulae in Arizona live. And there we go. Okay, we're good.
I just refreshed. It still says
It'll change.
okay. Please don't ignore us, folks.
No, they won't. They're already here. Okay, whoops. Okay. All right, now I'm going to set our exposure now to 40 seconds and start. Now, when you see our exposure of 40 seconds, it's over here. Okay, that's the exposure right there. You see that? Okay, that's the progress bar. Okay, this right here is our telescope control. This right here is our telescope in the building. That's our telescope computer. This is our camera control right here with those two parameters I told you about. This is our focus system over here. And this is me. All right, so let's now look at our first image. It'll be here in 9 seconds. Hey, James Dugan. Hi, Michael Galea. How are you? Terry Haig, what's happening? Randy Harris is with us too. And Randy says, hello, Morph. You know what that is. Morph is Marianne's nickname that Randy gave her. Ooh, let's clear this because we got a new one coming in. All right. Dean Bostador, how are you? Dean says, I won't ignore it. Marianne goes, Harris. Randy's nickname. They're all friends. Marianne, Randy, and Diane. They're all good friends. All right, 1 second. Ready? Here we go. Boom. And what do we got? Oh, look at that. Look at that. You can see our blue nebula here with dark nebula. This is just a stunning, stunning nebula. It's called Dreyer's Nebula. And we'll get to see more of it. And then over to the left is the beginnings of the Christmas tree cluster, which is sort of out here. You can't really see it. It's out of the picture. But this right here, this is the beginning of what's called the Phosphor Nebula, which trickles down into the Christmas tree cluster over there to the left. So you get to check that out too. But look at this. This is beautiful.
We scroll up a little bit.
Yeah, this
Or the scroll down.
Oh. So go down to the bottom, you mean?
Yeah, I want to see the dark nebula above the blue nebulosity.
Oh, that means, yeah, so I have to go back to the top. Let me just do that. Okay, 1 second. We're piling up commands here. I'm not even touching it now. I'm just doing this. We're good. I just gotta do this. There we go. And now we gotta do.
Very deep chunk of nebulosity there. Dark
Well,
nebulosity.
there is. As a matter of fact, when we actually get to look at it closer, what we can do is we can pull some of that detail out, okay, and do what's called a push. We can take this mid-level here, move it closer to our peak of data. You can start to see the dark nebula. Look at this. Now you can start to see details in here, and we can get our contrast back with the black background by just starting to move this one in. All right about there. Look at that. So now you can start to see these colors here, and if we give it a color correction, it'll move the curves just enough so you can start to see what's happening here. This is really pretty. This is Dreyer's Nebula. Okay.
Oh, it is such a busy part of the sky up there.
Isn't it though?
Yeah, this is Monticeros, folks.
Yes, it is. Yes, it is. Okay. And this right here is Dreyer's Nebula. Dreyer's Nebula is this region right up in here that we're looking at. Okay, so I will move that back down here so we can actually see it. Hey, Papa Tom, welcome. Good to see you. JSCO is with us. I didn't expect to see too many people tonight, being that it was Easter. But I guess we do. Nice to see you all. Let's do a zoom here because I want to show you a little more detail up here. There's some really cool detail in this blue reflection nebula. Okay, so what's going on in here is there's a lot of dark dust up here. And this dark dust is something that is really interesting. Let me pull the name out of there for now. The dark dust is interesting because it's carbon atoms that are bonded to each other, carbon-carbon atoms that make a molecule of two carbon atoms. It's silicates, silicon, and other ices and so forth. And what's neat about this stuff is that if we zoom in on it, okay, you can see how you have that blue glow. Well, when you look at the sky, it's blue. And I've talked about this a number of times. The sky is blue for the same reason that nebula is blue, or vice versa. And it is because the particles of dust in this nebula that we're seeing scatter the starlight that's blue in the spectrum of the star. We have red, orange, yellow, green, blue, indigo, and violet in our spectrum, and our blue light in our spectrum is scattered by the nitrogen and oxygen molecules in our atmosphere. And that scattering turns our sky blue everywhere you look, because the rest of the light is just passed through, which is why we can see the sun in the sky and so forth. But the blue light is just scattered and sent every direction. No matter where those atoms are, it's sent all over the sky. So that's why you can be looking 90 degrees from the sun, behind the sun, the opposite direction of the sun, and still see blue sky, because the atoms are being scattered all throughout that region. Same thing's happening here. Okay, we're seeing the very same thing. All right, these particles of dust are scattering the blue light from the stars, and the particles of dust that we're looking at are tiny. They're only a few microns in size. Okay, and microns are very, very small. So this cloud, all right, will have stars in it, and this glow is just the starlight being captured by the dust and redirected, basically scattered. Okay, now it's going all through here, all right. It's all through here. It just so happens that there's a little bit around this star, and then not any out here. So you know that these areas in space, there's concentrations of dust enough that we'll see the clouds. Also, you'll notice right here a very interesting feature happening right here. This guy, as you zoom in on this, all right, okay, there's some weird bands of dust in here that are interesting here as well. Again, we don't know and can't predict how dust is going to be laid out in the universe. We just know that it's laid out in a way that's pretty interesting looking. And so you can see these beautiful little clouds with knots of dust in here, and we see that all throughout our galaxy, because dark nebula is where it's at. I've said this many times. It's where life comes from. Look at that little wave right there. See that? That's very interesting. And then that one.
Mark, have you ever heard of the Hecate Nebula?
No.
Darlene asked about it with Elisha Virus.
Yeah.
And I did look. I posted a link there, folks, that OpenSea.io link. It is a pretty little nebula.
Where is
I have never heard of it before. I have no idea where it is.
What's its actual name? Has it got an NGC number or an IC number? Or
Not that I see.
Sharpless number?
Not that I know of. Not yet.
Okay.
It is a pretty little nebula.
Well,
unfortunately, the one picture I found of it doesn't say where it is.
Okay. Oops, something went wrong. Okay, I can't look at that. There's Mars. Okay.
pronounced Hecate.
Hecate.
Hecate, yes.
Okay. Well, let's try something here. Let's see if it's actually known to our planetarium system. Wasn't
Hecate was the great goddess of magic.
Yeah, I was gonna say it sounds like a Greek guy. Okay, it's not known by that name. Well, why don't you do this? Why don't you look up the Hecate and see if there is a number we can find it with, and first of all, find out where it is.
Exactly. Well, that's what I've been doing.
Oh, okay.
That's what I've been trying to do.
Okay.
Let me continue for the moment.
Hello, Sam S. We've done 15 of these so far. You'll notice that you see bugs flying around in the observatory. Yeah, because they're here still, you know. They're definitely flying around. Okay. Really nice. This red glow is really pretty. And we'll move over to show you where the red glow is coming from in just a minute. Let's go to 25% here for just a minute. So there's the entire frame. You can see the Phosphor Nebula up there heading down, and we'll be able to see that better in just a minute. Nice. All right, so let's do this. First of all, let's go full screen, shall we? And let's give ourselves the benefit of seeing a really cool image developing here. That's nice. Right. So the Phosphor, as I said, is over here, and it goes further on down to the left, which we'll see. And this is our beautiful Dreyer's Nebula. This is a little cluster that is just to the western side of the Christmas tree cluster. So we're going to see another cluster here in just a minute. Oh, look at that. That's pretty. Yeah, look at that. So this, when I was telling you, this right here, this dark lane right here, that is an example of the dark dust in the universe that is in molecular form. 2 carbon atoms together, maybe some silicon atoms in there as well, and an assortment of other stuff. And then this is that scattering nebula that we're talking about. These are dark nebula as well that are really hard to see because we're not exposing them very long for us tonight. But I bet you we could pull out detail on them right now if we give it a shot. So we'll try that. It's kind of cool. So let's do that. So first things first, let's bring back our telescope here. There we are. Okay. And bring back our stack. And now what I'll do is I'm going to pull this over just a little bit. Okay. Move this over. There we go. Move it down. Okay, so now we want to look at if we can find any detail up in here. So that's what we're going to try now. So first thing we'll do is we'll dock our stack back to our window. Okay, there we go. And now I'm going to really push this. Okay. Now you can see a little more detail up there. All right, it shows pretty nicely. Now what I'll do is I'll bring that down, and now I'm going to see what else is there. This is going to be a major push to pound some of this detail and see if it's out there. And we can see there's a lot of detail left in there. Okay, that's sort of an over pushing. All right.
Mark,
yeah.
the Hecate Nebula. It's labeled DSA 8 at one location, and I did a. Does that ring any bells? DSA 8, DSA number 8.
Sounds like some kind of survey, which I don't know. Well, what constellation, Red Ascension? Do you know that?
No, no idea. No idea.
Oh wow.
Very little on it is coming up.
Which probably means that it's not very noticeable. It might be very small. Hey, Rocket City. This is good. Okay, we're gonna pause this here. Dreyer's Nebula. We'll save it right here. Save it exactly as seen. Now let's go see what Dreyer's Nebula is connected to. What's over to the left here? Well, we're going to get out of here and go back to our night vision mode to help us pull that out. And from the night vision mode, we're going to move this star right here over to about here. So that means we're going to head east. And wait for that star to get over near the edge.
Oh, Mark,
Yes.
thank you, Robert Waters. Deep Synoptic Array, DSA.
Okay.
Bill wanted to know if we'd look at FIRSSE at 213 again.
Oh yeah, we can do that. Okay, so right now, to the left, to the east, we should say, of what we just saw, we have this nebula. The Phosphor Nebula is up here, the thing we saw, and it goes all the way up out of the shot, up through the 232710. And then this is the Cone Nebula down here that you'll see very soon. So let's wait for us to guide. We're starting to guide now. You'll see the telescope's aiming over a little bit toward the west. And we're going to take ourselves to another 40-second exposure and watch what comes through. Here we go. And we will get out of this out of night vision mode and go into our live stack. Remind everybody of what we saw. This is what we have here. This is Dreyer's Nebula. And now we are going over in this direction, moving the telescope in this direction. All right. And we will see more detail. We'll see this little cluster, and we'll see where this comes down and intersects. So let's clear this. It's already been saved, so we're good. There we go. And let's move this over now. Very complex area. Here is that area here that I talked to you about that's coming down in here. That cluster is over here. And let's color correct and give ourselves some processing here. There's the cluster. Okay. And there's the Starlink satellite. Now let's bring this over. What a beautiful thing. There is that arc we saw. And that comes down to complete the Phosphor Nebula in here. Very nice. You can see the Cone Nebula right here. It looks like a cone. Alright. This is the Christmas tree cluster with that blue nebula, which you now know is a nebula created by scattered starlight, because it's dust that's doing the scattering. It's not an active ionization going on like it is for the red that you see in here. That's hydrogen being ionized. Yeah. Now, you might say this satellite is ruining this image, but that's only on one image, and we're taking more images afterwards. And the black of the stars is the black of space is actually overlaying this satellite image for each exposure. And over time, that satellite image, that satellite trail, will literally be almost invisible. And I prefer to use that than an artificial satellite trail removal algorithm. Hey, C&D boy, how are you? Izabela is saying the old music playlist is back. Well, yeah, okay. Well, let's, that's music that I don't have to worry about licensing, and it's free. Yet, I'm discovering that these unscrupulous music industries are actually flagging the free music as copyright material, trying to steal what little we make off of this. They're trying to steal it. So I challenge it every time. I do 2 to 3 to 5, 10 disputes a week on music that's free. And I win every time, but it takes time. I don't lose in between, so pain in the butt. But you know what? Somebody's got to do it, right? And hey there, Robert Waters. I know I didn't say hi to you yet. How you doing? Happy Easter to you. All right, let's Isn't this beautiful? Look at this nebula up here. Beautiful dark nebula up there. That's the one that arcs in that we saw before. This image will perfectly mosaic with the previous image we did. And here is the Phosphor Nebula coming down here. It's just beautiful. Look at it come down. It has this reddish, weird brushed look like fox hair, fox fur. So it's called the Phosphor Nebula. Very complicated region. Let's go down more. This is down the bottom. So this is all dark nebula in here. It's not a void. It's not lack of stars. The dark nebula is hiding the stars behind it. Curtis says, Mark ahead first light with the new small EAA, electronically assisted astronomy, set up last night, posted on cloudy nights. Images weren't great, of course, because they were through my window. But hey, I'm glad that you did it. That's fantastic. Bill, he's asking how Bill Skywatcher is. Bill is hanging in there. He's our producer for our Sunday night radio show, Sky Tour Radio. And he's doing all right, hanging in there. Thank you for asking. I'm sure he would like to know that you did. Thank you. Is it just me, or is this looking more three-dimensional tonight than it has been for a long time? Let me
it's
just
okay.
get rid of this. And let's do this again. Pull that away. This is looking pretty. Look at that. This is really pretty.
Mark, will you excuse me a moment, please?
Sure.
Be right back.
Okay, so this right here that we're looking at is the Christmas tree cluster in the Cone Nebula. Let me move that down a little bit so you can see. Okay, I'll move it up actually. This is the cone right here. That right there is the cone. Let me, this right here. That's the Cone Nebula. It has two little stars at the top, and then we move up, and we have the Christmas tree cluster. And this nice, beautiful fox fur looking object is the Fox Fur Nebula. And it's all connected all up through here. It's just beautiful. So we are really having a good showing tonight. Really good showing. Hello, Sam Alexander. How you doing? You'll notice, remember I told you how that streak, which was very bright, will be all but invisible? Look at it. It's almost gone. Doesn't take much. Let's pull it down. And let's remove the object name because we don't need the object name right now. So you can actually see the beautiful nebula itself. Very pretty. Roy the boy, how you doing? Judy M, how you? Nice to see you. And if some of you aren't subscribed, please subscribe. You know, I mean, you know, this is something that honestly, no one's doing this. There's no one doing this on YouTube. Yes, they're doing streams, but they're not doing an entire production like this where you actually see objects and learn about them. No one's doing that. I don't understand why. Let's bring the telescope back here. Okay. That's pretty. I don't understand why no one's doing it out there. I just don't. Alright, and this is... Let's bring this up. We spent several years perfecting all the equipment to do what you see and then getting it out there. I ran it for several years on my front lawn here, and the telescope I used to do that was actually the one that's right there behind me. Okay, I just went and did that. Let me see if I can highlight that for you so you can see it. Okay, so right there you can see it a little better back there. It's actually facing us, facing away from us. But that's the telescope that we're using for the East Coast here. And we have a telescope for the West Coast that you're viewing through right now. And we have another telescope for the West Coast that we're doing, and it's not. This is a wide-angle view. This system here I will share with you is okay. Let's just go back and do this. This is the full frame you're looking at right here. This is 4 full moons across and 3 full moons tall. All right. The new system is only going to be a fraction of a full moon across. So the Cone Nebula will be, let's see, let me see if I can approximate it. Okay. This might be too many. But there's the Cone Nebula. That's going to sort of approximate. That's about the field of view we'll have natively with the system. So it's going to be really pretty, really nice. Okay, so I think that's about right. Yeah. Okay, so let's come out of there. So that's going to be yeah, and that's actually, we're going to have that in another couple months. Another couple months. All right, let's go back to our stack here. We're at 17. We want to do it roughly the same as the previous, which I think we did 22. So we're almost there. And then we can work on getting the mosaic done. Izabela's with us tonight, so Izabela may very well get the mosaic done and available to show you. I'm not committing you, Izabela. If you want to, you can. If you don't, that's fine. Because I can do it later. Yeah, Roy the Boy. He says, this does deserve to be subscribed to. It's a rare chance to see something exquisite. It really is. I mean, it is. And learn about it, too. That's the other thing, with... I am an astronomer. That's what I went to school for, and I chose to go into public outreach. And as you can see, woohoo, and this is so cool. I look at this, and I know what's going on in here, and rather than just a pretty nebula, we can talk about what it means to you, what it means to the Earth, what it means to the universe, and that is just the coolest thing. And as promised, look at that, our Starlink trail has now gone from that bright white to almost impossible to see now. And that's just how it works. So I let that happen. Jeremy B, how you doing? Nice to see you. Michael Galea. And then he's saying, hey, has anyone seen any pictures of the moon from the South Korean moon orbiter? The moon is littered with what I would say is objects, but I don't know if they're... I don't know, but there seem to be structures on the moon, is what you're trying to say. Yeah. The moon does have some oddities on it. I err on the side of thinking, well, maybe these are natural objects seen in an extraordinary environment where you can't tell how big things are. The Apollo astronauts were, when they were in the Taurus Littrow Valley, they were seeing mountains that looked like they were only just a few hundred feet away, and they were many miles away. So without atmosphere to give you scale and depth, you just don't know. Daryl, look at this. Look at this beautiful element of the Fox tree. See that? I don't know if you're...
Yes.
Yeah, there you are.
Sorry, I was muted.
Yeah. That is really pretty. A lot of detail in that. Okay, we have one more exposure here, and then we're going to go to do a different object. This is just a pretty object.
Pretty bunch of objects.
Yeah, actually, you're right. Okay, so we'll pause this. We're gonna rename this. We're gonna call this Christmas tree, and we already have it labeled. We know what it is. Okay, it's there, saved in the astronomical format, and then saved exactly as we see it. Now let's try to pull a little more data out. Let's try this first. Let's see if we can punch it up. Yeah, see, now that has a little too much noise in it, okay, but you can actually see more detail. This is kind of what's buried in there, and when we process this, we'll pull out all that detail and make it look really, really pretty. Okay, so there we go. Really nice. Now, when we say we're saving it, where are we saving it to? You might have noticed Izabela and Daryl and myself talking about the fact that these pictures we're saving are going up to our server, and they are. The server is located off of skytourlive.org. If you go to skytourlive.org right here, okay, you can end up going and checking out all of the photos you see tonight. We have a database, not database, well, a server, and you can go back and look through a year's worth of data, years plus worth of data, and that is thanks to Robin Curtis, who I think was Robin in the chat tonight. Don't know if she was.
She was.
Okay, Robin, thank you if you're still here. So that data is available, and we're also working on a database. We have a database. We can search it already and see, pull out important data to see when we observe certain things, and then look at the images. We're going to make that publicly available as soon as we can finish that process. Okay. So, since I did this again, I'm going to do this again. All right. Beautiful Christmas tree cluster. Okay. And in night vision mode, okay, this is all you see. All right, now let's get our computer up here. There it is. And now, what would you like to see, Daryl? There's so many things to look for.
Are we close to FIRSSE 213?
Yeah, that's what you want to see.
Is it in the neighborhood?
We're gonna find out. Let's see if it's down the list here. It was labeled as FIRSSE, right?
I don't remember. I think so. FIRSSE.
Yeah, FIRSSE 213. There it is. And we are in the neighborhood. It's right near Canis Major. Here we go. Let's go check it out, guys.
Okay.
We looked at this the other night. A really interesting little object. You see where the telescope's pointing? It's basically pointing up over my head now. You know, there's FIRSSE 213. Right there. And tonight, the sky looks a little nicer, so maybe we'll be able to capture it with a little longer exposure. And no moon. Okay. So you don't see it, but there's a nebula here. But you'll see it in just a minute. Okay, we're guiding. Yeah, we're at 300 gain over here. We're going to do a 45-second exposure. And it's off and running. There's our little yellow progress bar down here, moving slowly across. So we will go into our live stack, all right, which we're going to clear, but this is where we were just now. All right, so say goodbye to the Cone Nebula here, and the Christmas tree cluster, and the Phosphor Nebula. But it's up on the server for you to see. All right, here we go. There it is. There's FIRSSE 213, a small hydrogen cloud. An emission nebula, as it's called. Okay.
Oh, the ladybug.
Yes. Yeah, we saw this last time.
Yeah, Izabela did a nice rendition of it, and that dark line running up and down on the left side.
Right here.
Yeah, I thought sort of separated the head from the body of a ladybug shape. That's what it reminded me of, anyway.
All right. Well, it's known as FIRSSE 213. That's the name. And FIRSSE actually stands for Far Infrared something Survey Explorer. It was a rocket-based system that was launched to look at this, among other things. Far Infrared Survey Satellite Explorer? Or Solar System Explorer? I can't remember. It's not Solar System. It had to be... James Dugan wants to see the Orion Nebula before it's gone.
Terry Haig, you asked for Messier 94. That is not the cat's eye. It is a, spiral galaxy, I think. And yeah, Ken has been teaching. We should be able to look at that. Yes. The cat's eye is a planetary nebula.
which is really pretty.
Yeah, and I don't remember what constellation. Gemini?
No,
I forget where the cat's eye
that's
is.
the Eskimo, isn't it?
The Eskimo is in Gemini, yes.
Yeah.
Messier 94 is a nice spiral galaxy. It's sort of a steering wheel galaxy, and Kenneth's been teaching the hunting
Yeah.
dogs.
Can you send me Izabela's mosaic that she did so people can see it?
Yes, I'm getting ready to do that right now.
Thank you. Isabella, thank you for doing that. That's very kind of you.
I'm getting pulled about 10 ways at once.
Oh, I'm only being pulled 7 right now, so, you know.
Hang on.
Yeah, to do what we do, we're always multitasking. I've got to pay attention to actually 5 different things and then make sure that 2 other things are aligned and doing their thing. So, I have 2 monitors, but then I have 2 eyes, so I can just look at both, right? Well, thank you, Izabela. Oh, there it is.
Yeah, do you have it?
I do.
That mosaic?
I do.
Okay.
All right. So, folks, let me show you what it is that Izabela just put together. This is, remember we shot the Dreyer's Nebula with the blue reflection nebula? And then we moved over and shot the Christmas tree cluster. Well, this is what it looks like. Look at this. Wow. This is beautiful. Look at this. I mean, we have the blue nebula, which is actually over here. You can't even see it. That's how big this is. Okay, and then over here, we have the wrong thing. Over here, we have this beautiful cone nebula here, and the Christmas tree cluster. There's those beautiful dark nebula coursing all the way to Dreyer's Nebula over there, and then Dreyer's Nebula continues over that way. Look at that. Isn't that something? And we'll make these available to you. Our patrons will get this for sure. And this isn't even processed. This is actually just the raw footage, the raw process. We haven't even fully processed it yet. What were you gonna say?
Terry Haig asked about the Cat's Eye Galaxy, M94 she called it.
Okay.
The Cat's Eye Nebula is a planetary. It's in Draco, which is between the Big Dipper and the Little Dipper. So it might be up now. It should be up now.
Okay, we can check it out. We'll do a few more here.
Messier 94 is down in Kenneth Venetici.
Yep.
Down by the tail of the Big Dipper, the handle.
Yep. And Simon Thompson, thank you. I knew it was close. It was Far Infrared Sky Survey Experiment. I knew survey was in there. Did I call it sky survey or did I space or what did I say? I might have said sky. I don't know. I knew it was Far Infrared Sky Survey or something survey experiment. Thank you for that.
Yeah, we went through that last time. We added up.
Yep. Yeah, I just think it's pretty impressive. You know, I love how these objects sit out there. And I just think of it in a really strange way. I think, you know, the light from this traveled thousands of light years, thousands of years to get here. And we see it, and it's gone. And we may be the only people on Earth watching it right now. The only people seeing it.
See, that dark line is more sharply defined now.
Yeah, and there's a reflection nebula up here. One right here, too. This is a dark nebula around this thing. And you can see on this side, it's got a little bit of a reflection nebula. On this side, it's got a little bit of a reflection nebula, too. And then there's a denser part in here that's keeping the reflection nebula from showing up. But then there's more down here. It's really something. That's pretty. Okay, this is 10. We're going to save it here. And this is FIRSSE 213. And we'll save it exactly as seen. And what's the next? What's the galaxy?
Messier 94.
Okay.
Cindy, I'm glad somebody besides me sees a ladybug.
Oh, yeah, right there. You clearly see a ladybug.
Oh, yeah. It helped it had dark spots on his shell.
Oh, yeah.
But
well, we can fabricate those. Yeah. Okay. All right. So, if we were gonna go to see Orion's Nebula, the next stream we'll go because right now it's only 20 degrees above the horizon, and that's gonna be by our far side wall. So. These are pretty low right now. So what was the galaxy that we wanted to go to? Messier what?
Messier 94.
Oh, okay, we've seen that before. Okay, this is a viewer request.
And it may not be high enough yet.
Alright, well let's go see if it is. I'll tell you in a second. Let's go look. Oh, I don't know. It might. I'll try it. Let's see where it goes. Let's give it a shot. Alright, so we're running all the way over. The telescope's going to go whipping around. Lean way back. Lean back and say hello from the other direction. And let's watch what happens. I think it's high enough.
Okay.
Yeah. Yeah, see, it's high enough.
Terry Haig gets a twofer tonight, hopefully.
Hello, Hunter.
We'll show her Messier 94.
Which is right there.
And the cat's eye.
Okay. Good. Let's actually bring the telescope this way. Move a little west. Pull it in. Is the cat's eye up?
It's in Draco. Draco is between the Big and Little Dipper.
Oh, we're gonna see where we are then, maybe.
Sort of wanders, though. Let me.
All right.
Let me see.
Okay. Okay, so let's do this. Alright. Alright, we'll go right there. Let's check the centering. That's not bad. C&D Boy offered this nice information. He says it was discovered by Pierre McCain in 1781 and cataloged by Charles Messier 2 days later. Are you talking about FIRSSE? No, you're not. You're talking about this guy, right? Messier 96, 94?
94.
Okay. We're guiding good now. So, let's go to our 1 second here for a minute and see. See all the detail here. Yeah, this galaxy is gonna look pretty. Okay, let's just do a 20-second shot of this because Our telescope is 25 times faster than every telescope of this type. Actually, that we have the only prototype of this in the world right now for this particular brand telescope. So what we're showing you is stuff that no one else can show you with this type of telescope. Oops. Let me just clear that. That's up there already. So 10 seconds. Good night, Elisha. Sorry. Here we go. And let's process and show. Wow, look at that. Is this one of those SA zeros?
You got me.
I'm gonna guess it's an SA zero.
Give me just a second, I'll find out.
Oh, I got it right here. It's an SA. Okay, so it's basically it's between an A and a B. So there's some spiral arm structure, but it's not a spiral arm structure that is as notable as with a less windy galaxy. This one is pretty wound up, but if I do this, we can probably zoom in, which is why I only did 20-second shots.
Well, there's two parts. The inner part is pretty wound up,
Yeah, I
and
see it.
the
Look at
outer
that.
part is almost like a halo around it.
Mm-hmm.
That's why I called it a steering wheel galaxy.
Yep, there it is.
It's interesting. I don't know if we'll see the outer part or not.
Well, I only did a 20-second exposure because it's so bright. Okay. Yeah, let's cut some of the brightness. You can see some modeling in there. We're just sifting through the brightness. Oh, look at that. You can see some definite spiral arms in here. Look at that. That's actually pretty fascinating. We can actually take this back a little bit. Okay. See all that detail in there?
Yeah, that's all the inner part. You can barely see that outer ring around it.
Well, I certainly can if I open it up more.
Mm-hmm.
But it looks like it goes all the way out here.
Yep.
You can see that right there. That would probably be clearer as we expose more. But again, I only did 20-second exposures. I wanted to preserve the inner core just enough, but it still is overblown. Look at that ring. Hey, Natasha Nix, how are you? Natasha said she took her daughter to Lowell Observatory last week for her birthday, and they had a great time. That is fantastic. Lowell is one of the most famous observatories in the United States. That is very cool. I worked in an observatory with a telescope that was kind of around the size of the Lowell telescope. It was a 20-inch refractor that I used. So that was like 35-foot long tube. The whole floor moved up and down to meet the telescope. Look at this detail right here. Look at these. You can see dark parts of the spiral arms here. See that?
Uh-huh.
That's really pretty. Let's do this. Yeah, look at that. You can really see some stuff in there.
the outer halo is barely showing.
Yeah, if I did a 50-second or something,
Yeah.
we'd see it more.
Izabela was asking about it. Something like a dark ring. Izabela, there's a dark ring, and then there's a faint light ring outside that dark ring there.
Yeah.
The dark ring is actually sort of a space between the inner and outer parts of the galaxy.
Yeah. Well, this one's called the Croc Galaxy. Okay. And I can see that I'll save it, but I can see that we're gonna be refocusing here. Just a second. Let's do this. Let's we'll call it Crocs. No, we'll call it M94 because that's what it is. And I'll say Croxi. And I'll say GAL because it's a galaxy. Alright, and we'll save it. Save it like you see it. Okay. Okay, now we're going to get rid of the stack. Go back to our 1 second exposure that we use for our night vision mode. There's night vision mode. Now we're going to do a adjustment on the focus. So we'll do that again. And this time I'll turn on the temperature compensation. Okay. So it's using the whole frame, and we're just looking at a section of the frame, but I can zoom out and you can see all the stars it's using because it's using 17 right now. Alright, so we do this. Boom. There we go. And that count increases as the focus comes in. And then it will decrease. It's up at 67 now. 70 stars. And then as it goes back out of focus, that count will drop. And then when it finally does drop to a point where it can't focus anymore, or it sees that the focus is way out, then it's going to stop and it's going to find the center of the curve. You can see the center of the curve forming right here. And we're going to see a line show up right about here to make the focus. There it is, right there, as I pointed out. Okay, and that's the most critical focus. So that looks like it's pretty good. So we're going to do the refocus here. Hello there, Petita.
Is your temperature compensation on?
Well, I just said that I'm going to put that on right now because I didn't have it on before, which is why this happened. So now that we got that, we know what it looks like there, let's now do a 35-second exposure of this guy and check out how it looks. Let's see if the ring is more available to us. What do you say to that?
Sure.
I hope everybody had a good Easter, and I want to welcome you guys from your Easter celebrations.
Sam S. has a question. How does the guider choose the stars to guide on?
The nice thing is that's an automated process. The guider has a wide enough field, but it can focus on one star, and it can then, like, okay, here's an example. The guider sees some of the stars around here, okay? Some of the stars around here. So it's guiding on one of these, but it doesn't have to be in the center of the field. It just has to guide on one of those stars and make sure that one of those stars stays on its crosshairs that it defines internally, okay? So basically, internally, it's doing this. It's going to put up these crosshairs, not like that, not like that, probably like that. Okay, or a double set. Okay. I don't have any control over the star that it selects because I want that out of my control. Ronald, ERT Radio, says, on my scope I have star sense alignment system. Yeah, you have star sense, that's correct.
This is a very complicated galaxy. There's a multispectral image of it in infrared, different wavelengths and stuff, that shows a lot of spiral structure that we're not seeing easily.
Okay.
It's a spiral galaxy, Ronald.
I can see an arm here. I can see two arms in here. They're very tightly wound, and then they get looser outside. There's some dark material in the galaxy here. So that's good stuff to know. Too low. Cat's Eye Nebula is too low.
Yeah, I meant to tell you that I looked it up on Solarium.
Okay.
It's looks lower than Polaris, so.
Yeah, well, it's significantly lower.
Yeah.
See, for our observatory, we can see right to just below Polaris. And we're about an hour and a half, 2 hours away from being able to see it, just barely. But we're up here, which is good. And we're also in the region of Coma Berenices as well. There we go. Okay, then. And
you want to see that composite, Mark?
Yeah, isn't that the one I already showed?
What?
The composite. You talking about the Christmas tree and the dryers?
No. It's an infrared ultraviolet composite.
Oh, that. Okay.
Shows you what's really there.
Okay.
Now, the bright part that we're seeing in your image is just that yellow part, I think, or the first outer circle from that. And then there's a whole lot more going on. And
well, looking here, you can see this is the hole that we see.
Yeah.
And then there's the outer part going on here. So we see out to the hole. We don't. This is the inner part, the outer part, the hole, and this ring. We haven't exposed anything for farther out, but that's pretty cool. So that's the galaxy we just looked at. Fantastic. Thanks, man.
Okay.
All right. So that's this guy. Okay, let's Let's see if we can pull in some more details here. Let's zoom out a little. Okay. Well, we're not doing bad. I don't think we're doing poorly. That looks nice. Okay. And this is 11, so we'll go 12 and then we'll save it here. Okay, there we go. Save it. Croc Galaxy. Save exactly as seen. There we go. Alright. I would like to try. Is the Whirlpool too low for us right now? That's the pinwheel. Isn't the Whirlpool up here somewhere? That's Bode's Galaxy. Where's the Whirlpool? Down here? Canis Venetica.
Whirlpool?
Yeah, it's down here. There it is. We should be able to see the Whirlpool.
Sure.
Let's try that. Alright. Here we go. You'll see a mix of stars and trails and galaxy there for a minute. There we go. There's the Whirlpool Galaxy. This galaxy is really, really cool looking. So let's head up north.
I saw this in a 41-inch telescope one time.
I'm sure it looked beautiful. You said, actually, I think you said it. You had to climb a ladder to look through it, right?
Right. It was about 15 feet up in the air.
Wow. I would be afraid to climb the ladder.
Out in the forest in the middle of the night.
Wow.
It was spectacular.
Wow. This is pretty. Let's do 35 seconds on this. That seems to show it well. Okay. And our live stack, this is our previous galaxy. And we'll clear this. Hey there. Hey, wrong way, Feldman. I like the name. Cool. Remember Wrong Way Feldman? Wasn't he on the Gilligan's Island? Was that where it was? Look at that. down just a bit. We might lose some of the faint stuff, but we'll see the other stuff. Let's turn off unsharp masking, and it will make the core of the galaxy a little bit less bright. You can see more detail in there. And we'll run with that for now. Okay. Look at that beautiful galaxy, guys. Isn't that gorgeous?
Long-time favorite.
Indeed.
I remember one night many years ago, I was on a hilltop campground in a state park in the middle of a lake down in southwest Colorado. And we were looking at this, and it must have been about 1 or 2 in the morning. And it was me and one other guy. And I had the telescope set up in the parking lot.
Yeah.
We woke up the neighbors. They weren't very happy. They didn't appreciate the view.
So you were just loud and boisterous.
Oh, we were trying to be quiet. They were in one of those pop-up campers, you know, with the mesh walls. And
oh, yeah.
sound went right through it. The telescope was probably making as much noise as anything whenever we slewed it.
Wow, this is pretty.
It is. Can you zoom in a little? You already did, didn't you?
Yeah, but sorry. Let me let's get rid of the name there. Go away. There we go. Let's see if we can, if the unsharp masking will, it'll get rid of some of the detail in there, but it shows you more detail in there. That's kind of cool.
Yes.
Well,
Michael Hadrick has a question of you.
how many supernovae are in this galaxy? I
don't see any right now.
don't see any that don't look like they belong there. I mean, this one here, this bluish star, this bluish haze. If that's truly bluish haze, that could be a supernova remnant from a previous supernova that might have occurred. But I can't really tell if that's the actual color or if it's not just a association of hot young stars, because they're also going to be blue.
Now, Michael, I am not aware of any current supernovas in M51. It would be in the astronomical news, if not the regular news, if there was.
Yeah, we would know it.
We would know about it.
We would know about it, and we would be taking you there. But everybody pays attention to the Whirlpool, and they miss this little guy down here. Let's go see him. Look at that little galaxy right there, guys. That's mist. He's probably saying, "Oh man, the Whirlpool is stealing all the fun. I'm a little tiny guy down here. Nobody wants to see me." You're right. I just want to see the Whirlpool. Pretty cool. Nice. Very nice.
Mark, can you pull up Stellarium for a moment?
Yeah.
Can we ID that smaller galaxy?
Probably so. Not sure if it's actually. Oh wait a minute. Let's get our field of view. That's probably that guy right there. Probably this one. IC 4263. Active galaxy. Let's make sure. Okay, it's just to the lower right, and there should be another one down below further. And there is. Okay, so we have these two galaxies right there. That one is a little more clear. Looks like we got another one here. That looks like an elliptical or something. As does that. And another galaxy here. Another galaxy there. We've got at least one. Well, hold on. Let me show you. We have one additional galaxy here. Another additional galaxy here. And there's another one right here.
Another one to its left. Yep.
And these, this might be a galaxy. I'll have to check it out. There's a galaxy here too, which is kind of hard to see. The pixels are messed up a little bit. That's okay. All right, so that's pretty cool. So let's check that out. Okay. All right. So if we go now to Stellarium, meanwhile we're taking all these pictures. We're getting all this stuff. We have that galaxy. We have that galaxy down there, which is even better looking. And that is NGC 5169. Okay, that's a active galaxy as well. Looks like it has some spiral structure to it. And right near it is another galaxy, NGC 5173. It's an interacting galaxy. And then we have NGC 5198 right here. And if you notice the numbers, okay, we have this, we'd be looking down here. So toward the bottom. Okay, so up here is the Whirlpool. And down near the bottom is where we're looking. So we have 1, 2, 3, 4 galaxies. At least. That's pretty interesting. So there's a lot of galaxies. Yeah, and every one of these galaxies can have hundreds of billions of stars. So it's amazing. Okay. So that's 24 shots. We're going to save this. Whirlpool Galaxy is there. Save it exactly as seen. And then we can be free to analyze it. Okay. So we'll actually get rid of the stack now. Go back to our night vision mode. Alright. So you can see it's pretty bright because even in our night vision mode with 1 second exposure, the entire galaxy shows up. That's pretty good. Alright. That's cool. I like seeing that. Do one thing while I'm here. Little housekeeping. Oh, that's perfect.
While we're in Canis, you might try M63.
Okay.
And we've done M94, and there's also M106, which looks really interesting.
Mm-hmm.
M63 is a sunflower galaxy.
Okay.
And there's also M3 globular cluster in Canis.
That's true. I think that's a little southeast of us right here. Okay. Did you say Measure 63?
Yeah.
Yeah, there we go. The sunflower galaxy. Let's check that out. That's pretty. I know this is pretty. We've seen this before. There it is. Okay. Beautiful. Okay, let's we'll start our guiding here. It's going to be 14 seconds. You see the telescope is pointing up out of the back there. Okay, we're guiding now. Let's do 25 seconds, which is way long for galaxies like this because they are so bright for this telescope. Okay, we're gonna kill this and go into our stack. Remind everybody of our beautiful Whirlpool Galaxy, which is now up there. And off we go. And up comes the first shot of the sunflower galaxy. This is gonna be pretty. You're gonna like this guy. Oh yeah. This has the most beautiful spiral arms, and they're pretty obvious. You can already see them. And we only have one image stacked. Watch this. Watch how the noise goes away when you get the second one. Second one comes in and boom. It looks so pretty. Look at that. Look how clear that is already. Not bad, Daryl.
Yeah. I figured while we're in the neighborhood,
Yeah.
you
It's all
might
good.
try, what was it? Messier 106 also.
The pinwheel.
106
Is that the pinwheel?
pinwheel.
No.
That's M33, isn't it?
Mm-mm. No, there's another pinwheel in Ursa Major or Canis Venatici. Simon, NGC 5198 was in the last photo we took, actually, down near the bottom. Unless I misremembered that just now. Look at the spiral arms. Isn't this pretty? I gotta zoom in on this because it's really important to see these arms. Now we got a lot of noise in here right now, but we can remove some of this noise. Just like that. Now you can see that is really something. You can see all the way to the core of the galaxy. And we even have the unsharp mask on. Let's turn that off and it'll get even more visible. Look at that. Looks like a spinning plate of... I don't know why I was going to say ice cream, but a spinning plate of something that's swirling. That's cool.
Got another galaxy up at the top right corner.
I see it there. You're right. Let's see what that one is. Okay, so we're going to come in here and say, just give me some processing. Oh, there we go. Then you come down to this, and you can see that you have this beautiful modeled interior of this galaxy. A lot going on in there. A lot of turbulence. I would guess there's probably a lot of life in this galaxy, because it looks like there's many modeled areas in there that have dark nebula complexes.
Fengwei said there were 400 billion stars in M63.
Well, that's the upper estimate on ours.
Chances are good.
Yeah. RJPX, how you doing? Michael Hedrick says, best Easter egg hunt ever. Very cool. It's a universal Easter egg hunt.
Oh, it's galaxy time of year.
That's right. Sounds like a song. It's a galaxy time of the year. All right.
I saw a mention of Messier Marathon the other day. I kind of surprised it got by me.
Yeah, when we get it, when should we do that if we can do it? There's 2 times a year when you can do it. Right?
It
Realistically.
may have already gone by. I'm not sure. Let me look it up.
All right. Well. Boop. Sunflower Galaxy.
Looks like it's already passed.
Okay.
The best times was in March.
Okay. So that's the Sunflower Galaxy, and it's a beauty.
It is. Can you zoom in a little?
Yes. Now that we've got some data. I just yawned, sorry. First one. Okay.
Ronald, there are at least 6 big ones. Big galaxies visible in Leo and a bunch of little ones.
Look at that.
What is it? 65, 66, and the Hamburger Galaxy, and then 95, 96, and
Yeah. The one,
M105.
yeah, you just mentioned the Leo triplet, yeah. Just imagine how much life we might be looking at here. Right? There could be millions of civilizations or billions upon billions of life forms in this galaxy. That's incredible. Just the thought of it. There's
If you like this, if you
halo
like
outside.
and 106.
Yeah. That's beautiful. Well, this is 17. We'll go to 18 and then we'll save it and move on. Mm-hmm.
And there should be several galaxies visible in the field here for 106.
I think you're right. All right. So we're at 19. So we're going to
Big dark lane there.
save this here. And save exactly as seen. That beautiful dark lane in this one. Really pretty.
What did you name it?
Sunflower.
Okay. I couldn't read that.
And then we'll change it. Yeah, it shows up in the Whirlpool, so I have to change it. All right. Okay, done. Okay. So we'll get out of this now. Go back to here. To our night vision mode. Okay, and let's pop out and go full frame on this right here. And now we can go back to this and say go. And you watch the telescope move a little bit and take us up to it. Zing! Look where the telescope's pointing. It's pointing higher in the sky. That's all good. And there we go. Definitely galaxy season. This galaxy, Besher 106, is also known as NGC 4258. Yeah. All right. All right, we're searching here, and now we just started guiding. Curtis says, I wonder what they call our galaxy. It depends, you know, if they have surveys of their night sky, which if they're curious, they would, then I suspect that they would have a name for us, and we may not know that name. Not until we meet them. We call your galaxy garbage heap. What? 30 seconds on this one. And then go into our stack. Clear the last one. No. Right, there we go. RJP, yeah, it's true, you know. That's part why I became an astronomer, because I felt that there was people looking back at me, or beings looking back at me whenever I'd look up at night. It just felt weird to me. This is pretty.
At least 5 galaxies in that field.
Yeah, 1, 2, 3, 4. And that one, of course. And then there's another one over here. That's 6. And then if we look over to the right, down below, there's a faint one right there. Another one right there, very, very faint. One right there. So, you know, one right there. Lots of galaxies here, folks. Lots of galaxies. This one is a stunning galaxy.
If we build up a few exposures and can zoom in on it, the very unusual spiral structure in the center of that one, kind of disturbed looking.
Yeah, it is.
Looks more
irregular to me than anything else, but I'm sure it might be a barred spiral.
The part to the upper right looks more spread out and kind of disturbed maybe than the part to the lower left, the different spiral arms.
Looks like it goes out to about there. See that? It goes out there.
Yes.
Wow. That's pretty cool.
And on the inner spiral, there's a dark bar cutting across the lower leg of it.
Yeah, right there.
Yeah.
Almost looks like a circular thing. Right here, these are either young hot stars or supernova remnants. Lubo asked if there's any bright supernovae yet, and not that I know of, Lubo. We just have to keep our eyes peeled. But look at that. That's really looking like it. That's something. Well, while we're waiting, let's back out and see how many galaxies we're looking at. Okay, let's get the whole frame in here. Here it is. Well, we have over here, we have that one. We have 2 right there. 3, 4. That one has that's an edge-on galaxy. You can see the galaxy's edge facing right at us. You can see the dark dust lane going down the center of this galaxy right here. That's pretty wild. That's nice. Curtis is suggesting NGC 4725? 4725?
Yeah. It's in Coma Berenices.
Okay. This galaxy is pretty interesting.
It is. Michael, I hadn't heard anything in particular about that. I know they're looking and they are finding stuff that is hidden behind the bright part of our galaxy. Other galaxies and satellite galaxies to the Milky Way, dwarf galaxies and such. I don't know about any particular technology that they're working on to see through the center. They call all that the zone of avoidance. Because we have a hard time seeing through it.
Yeah. So don't look in that direction, ladies and gentlemen. Nothing to see here. Okay. And this, boink, is measure 106. Pull down. There we are.
Cool galaxy.
Yeah.
And you see 4725, it's an intermediate barred spiral galaxy with a prominent ring structure.
Well, we're going to have to check it out.
And Coma Berenices.
Let's see if it's high enough. Okay, so this is cool. In galaxy season, we go. Alright, so now let's go back to our planetarium program and find 4725.
It is on the small side, I think.
Not sure it's high enough. Yeah, I think it's still too low. Oh, wait, let me just do it.
Oh, it's just,
It might actually be okay.
yeah,
Okay, let's
kind
try
of above and between Leo and
Yeah.
Virgo.
it. Yeah, give it a shot. There it is. There it is. Let's check it out. Go away. Alright, we're going to head east. And I'm going to head north. We have another galaxy right there. Alright.
I see at least 3 galaxies on a 1 second exposure.
Yeah, I see 1, 2.
Top left.
Up there? Maybe.
Yep.
Yeah. Alright, let's do this. Let's give ourselves a 35-second exposure. Now, if you're asking the question, what makes me determine what exposure we use, it's just experience with objects of certain brightness. That's all. We're going to clear this. And clear that. So that's up on the server now.
That's cool.
It is. Alright, and in 5 seconds we will see this. This is exciting. Let's see what we're going to see. They're just getting better and better. Oh, look at that. That is a beautiful galaxy. Wow. Wow, guys, this is pretty. Um, if you're at this is 4725. Let's thank Curtis Horn for this one. Is Curtis the one that suggested this? I believe he did.
I think it was, yes.
Well, thank you, Curtis Horn. This is a marvelous choice. We've looked at it before, but it's always good to see it again.
We have.
Yeah, we certainly have. Let's look at all the galaxies that might be in there. We have 1, 2, 3. And then we'd have to zoom in and just scan. Going to the galaxies. This one has a little spiral structure all its own. Check it out.
Uh-huh. RJP, if it is, I did it accidentally. I'm sorry. Well, you mean you hear my breathing?
Yeah, that's why I got to get you a different microphone. Okay, so let's do a color correction here. Get our sky the right color. Look at that. That's really pretty. That one there, I think that was one that Curtis was saying was NGC 4747. Is that a starburst galaxy by any chance? It looks like it might have starburst galaxy characteristics to it. Runaway star formation caused by potential interaction with other galaxies. Look at that. Let's zoom in on this. This is a good call, Daryl.
I'm sorry, say what?
This is a good call. This is a nice, good call in this galaxy.
Well, thank Curtis for that. Barred spiral. It's one of those, I call them steering wheel galaxies.
Yeah, they kind of look like that. And this, it looks like it has a spate of star formation right here. So when we look, you notice, guys, there's a little area right here that looks like it has a blue arc.
Uh-huh.
That looks like it might be what's called an OB association, a young hot association of young stars that just formed in the spiral arms of the galaxy. That looks like that's what that might be. And this music is great for this being a galaxy.
The arm on the upper left has a sharp crook in it.
Right here.
Yeah. And it looks like you see another fainter spiral to the outside of it.
Out here.
Yep.
It does look
Going
like
all the way
there's
down under
haze.
it.
Looks like there's haze all the way out here. Let's do a over process just to see what it looks like. And you're right. There is. Now let's zoom out to see that better. As you can see, there is more detail outside this galaxy as well. Let's get rid of the over processing. Really pretty. This is nice. We'll take this to 10.
Michael Hedrick has another question for you.
let's see. How many photons per pixel are how many photons per pixel here on the galaxy? Well, let's zoom in so we can see the pixels. Okay. Now you can see the pixels. These little square, that's 1 pixel right there. Now the number of photons is higher here, obviously, than out here. So I can't tell you how many photons per pixel, but I can tell you that it's obviously significant. So we're actually, our capture profile here, we're actually shooting, the camera is actually shooting at a resolution of 4,144 across by 2,822 pixels tall. So this is beyond high res for sure. It's beyond the 4K type definition of an image. Okay, it's not. It's beyond 4K. So we got 12 now. Look at this. This is really shaping up nicely. We'll save it here. This is NGC 4725 labeled as such. Save exactly as seen. Wow. Telescope's performing well, I think.
I think you're right.
Okay. So let's do this now. We're gonna zoom back out to full frame here. Okay. Let's go to our... Let's see. What would you like to see?
Well, if you're in coma,
Let's zoom in on Coma here to see.
Messier 64, Black Eye Galaxy.
Yeah, that's down here. I saw it earlier.
Messier 53, Globular Cluster.
Yeah, we've seen that. I like that.
4560, 4565, of course.
Yeah, can we see that now?
Oh, I bet you can.
I would think we can. Let's try that. 4565 is stunning.
Excuse me just a moment, please.
Mm-hmm.
Be right back.
Okay. All right. Oh, yes, we can. All right, this is really pretty. Away we go. And the telescope will zero in on 4565. Right there. Ah. This galaxy is literally almost fully edge on to us. It's almost like this. So you see this dark lane, and it is stupendous. Okay, so we're searching for our guide star now. It says searching. As soon as it labels one, as soon as it finds one, we have it guiding. There we go. Now we're going to do this at 35 seconds. And off we go. And let's go into our live stack. Remind you of what we saw last time. This beautiful 4725. And now we're going to take this one step further. I'm going to clear that. Alright. Alright, and now we'll just do that. Move on a little bit. Okay. 5 seconds. Look at that. This galaxy is a stunner. Oh, yes. Wow. Yeah, the whale galaxy is really interesting too, Curtis. He says there's the black eye galaxy, the whale, and pup, and the coma cluster of galaxies. Yeah, we're hanging out there for sure. Let's see if we color correct. We should be all right. And now, just bring us a little darker sky. Soften it a little bit. Daisy and Zoe, how are you? We have this beautiful galaxy, the NGC 4565, and then we have another galaxy below it. Which I don't know the name of that yet, but I will. Hey there, Prow. How you doing? Yeah, you did. You asked about the sombrero. And this is even more edge on than the sombrero. This one is very close. Let's zoom in on it and see. Look at that beautiful dark lane in there. And we only have 5 stacked. As we stack more, the noise will get knocked down even more. Okay. Very nice. Welcome back, Daryl.
Thank you.
This is also known as the Needle Galaxy or Berenice's hair clip. Did you know this was Berenice's hair clip galaxy?
It's the first time I've heard that one.
I know, right?
It kind of makes sense.
I guess it does.
Since Coma Berenices means Bernice's hair.
Right. Let's pop that out there. Pow.
Yeah, if you look closely, just under the dark lane, you can see the very nucleus of the galaxy.
Right there.
Yep.
Yep.
And this reminds me of something I was wondering last time we looked at this, I think. If you could rotate that galaxy about 90 degrees clockwise, so it's pointing to the upper left and lower right.
Yeah.
And if you cut it off a little bit to the lower right of the nucleus of that galaxy, that would be very much like what our galaxy looks like in our sky.
I guess that's, yes, because it's almost edge on.
Yeah. Yeah.
Yeah.
And, well, which side is rotating toward us and which side is rotating away from us?
I don't know. I'd have to look at a radial velocity study of the galaxy.
Yeah.
Because this could be rotating this way, okay, as seen from above, or that way as seen from the other way. There is no counterclockwise or clockwise in space. It depends how they began accreting material when they first formed.
Well, if you look at the left side compared to the right side, I think they're noticeably different looking in appearance. And I can kind of see that when I see exposures of the Milky Way that show, the right-hand part is what would be in our southern sky.
Yeah.
That we never see most of. But if you see images of the Milky Way that were taken from farther south, that would put the center of the Milky Way directly overhead.
Yeah.
That you can see both arms. The one side is notably different looking than the other side. The southern arm is different looking than the northern arm.
Well, and they will be, because we're closer to one side of the galaxy than the other, so it's gonna be warped in our favor compared to the farther one, which is gonna have less traversal, in the sky, because it's actually further away from us.
And I assume, but I've said before, what we see is that dark lane crossing
Right here.
the galaxy. That would be analogous to the dark rift that we see.
That's right.
In our northern arm of the Milky Way.
Right.
And we are rotating that direction, I believe, in the galaxy. We're heading vaguely in the direction of the star of Vega.
Yeah.
More particularly sort of toward a point in Hercules, I believe, not far from Vega. But then, and I assume that means that, our whole part of the galaxy is moving that direction as it rotates about the center.
Yeah, that's probably true. I don't know. Yeah, but for us, this would be where Sagittarius would be. Okay.
Yeah.
And then this up here could be where Cygnus is, and Cassiopeia and Perseus, or vice versa, depending on which side of the galaxy you choose.
Yeah. Curtis, I saw that. There was a very bright flash.
Oh, in the observatory?
Yes.
Yeah.
A little while ago?
Yeah, insects, yeah.
Is that what it was, an insect?
Yeah, well, you see the spider web, and you'll see moths and spiders fly through. This is an infrared camera, so clearly anything like that will just be like blazing light in the view.
Mm-hmm.
That's pretty. Look at that.
And Fongwei mentions something I'd read before. The NGC 4565 is much larger than Andromeda. If it was the same distance from Andromeda, it'd be a lot bigger in the sky.
Yeah, wow. That's cool.
It's a big fried egg.
Well, I mean, Andromeda's rumored to have about 2 trillion stars in it.
That many?
Yeah. That's one that, just look it up, you'll see it's rumored to have about 2 trillion.
Well, I never heard 2 trillion.
And maybe it's about was it 1 trillion? I'm getting tired, that's why.
You're what?
I'm getting tired, so I'm forgetting certain things. Might be over 1 trillion, yes. It was at 1 trillion for the Andromeda Galaxy.
1 trillion.
Yep.
So comparable.
Yep. Beautiful. let's sharpen that up. So you can see more detail in the spiral lines when we sharpen it up. Beautiful. Pull that down. Okay. Pull it down a little bit. There we go. Okay.
Well, I know the numbers keep going up for all of them. Arthur C. Clarke said once a long time ago, I forget which book, for every soul that ever lived, there burns a star.
Mm.
And at the time, the thinking was there were about 100 billion stars in the Milky Way.
Yeah.
And I know it's more than that now.
Well, yes, because you look at the sheer amount of nebula and dark nebula, all of that stuff, all this dark nebula you see here was made in supernovae. Okay. It was made in supernovae, and there was some primordial carbon around, but not. It had to be made in stars first, right? So we had hydrogen as the most predominant, then helium, and that went on for a while. And those stars that were larger ended up making oxygen and carbon, and so then it started to collect in these galaxies, in places where supernovae went off, and the supernovae littered the cosmos within galaxies with all of this material from its nuclear furnaces in the center of the stars inside those galaxies. And so we see this, we see all of this as basically, it's like a trash heap. It's a trash heap of the materials that make life in the universe. That's what this dark nebula is. Really, really cool. Good night, Terry. Thank you for coming. Very cool. All right, well, let's see here. I think we're at 22 shots here. We're going to pause this and save it here. And save exactly as seen.
Do one more?
Yeah, one more.
M64.
Didn't we just do that?
No.
We didn't, did we? Okay. We can do that.
The Black Eye Galaxy.
Oh, yeah, so pop goes the weasel. Off you go. All right. That's right. Black Eye Galaxy. Let's check that out. I think we should be able to see it.
NASA says at least 100 billion in the Milky Way, at least, and elsewhere I've seen it
Up as high as 400.
as high as 400 billion.
And I've seen it listed as saying almost 10% of the stars in our galaxy could have Earth-like worlds.
The one article that said 400 billion said there at least one planet for every star.
Oh yeah, that's on average now. M64. All right, well, let's go to the Black Eye Galaxy. So named because of it has a black eye of supernova debris, which is and there it is, which is a beautiful black eye of dark dust. Really quite astonishing. Let's move it up and just check it out. Hello there, Clifton Cormier. Thank you for that corroboration. Make sure you subscribe if you haven't. We really want to have lots of subscribers so we can actually keep doing this. It costs us a lot of money each month to bring this to you. So hopefully you guys can be swayed into joining our Patreon to help us out. This will be a 35-second exposure. Okay, then we'll go into our live stack here. And that's the previous shot of the NGC 45 Needle Galaxy 4565. And then we'll clear it in preparation for the Black Eye Galaxy, which is going to look pretty cool to you. Yeah, we're at 5 seconds until we see the Black Eye Galaxy for the first time this year. And there it is. Look at that. Wow, it's looking really pretty. We can already zoom in on this a little bit.
I don't see the black eye.
Yeah, you do. Let's do this. Make it a little more obvious. There's the black eye.
Okay, I can start to see it now.
Can't miss it. There it is. That's why this is called the Black Eye Galaxy, because it has this little curl of dark nebula around the center area.
Yeah.
There you go.
I always think of it as the I'd rather fight than switch galaxy.
Yeah, that's true. Yep. Fantastic. Let me just say ahead of time, guys, thank you for coming out on Easter Sunday to hang out with us for a little while. Pretty cool. All right. And so, blah, this is M64, the Black Eye Galaxy. Let's move that up into view. There we go. Boy, that's looking really cool.
Izabela asks, Mark, what do you think about this? She had asked, let me see here. Are the larger galaxies usually the older ones because maybe they had time to gather material?
I don't know.
I said, well, M87 is the biggest
right.
we know of right now, and it's in the Virgo cluster, and it's certainly been gathering material from other galaxies. I would tend to say yes. I don't know for sure, though.
Yeah, I think that it depends what type of galaxy you're talking about, Izabela. If we're talking about spiral galaxies, then that might just be related to how much material was available when they formed in that local area of the universe. So those can be pretty big. However, you also have, when you have bigger spiral galaxies, they tend to cannibalize other galaxies, and they get absorbed into their structure, and maybe that's where elliptical galaxies come from. So that's a possibility. But as you say, Daryl, Messier 87 is the biggest elliptical galaxy in the universe, as far as we know. It's massive. And it also has a black hole that's several times larger than our solar system in diameter.
Yep.
I mean, that's pretty big for a black hole. And then you have to say, well, how did that happen? And that speaks to the myth about black holes, by the way, that they basically say, when you hear about black holes, well, all the material is compressed to a single point in the center. No, it's not, and no one believes that. It's not true. It's actually, it has a definitive radius, right? And that has to do with how much material it's acquired. The more massive, the more mass that's got inside this black hole, meaning going through the event horizon, the larger the radius is. The radius, known as the Schwarzschild radius, grows with mass input. So you can calculate, in fact, how much the black hole's mass is, and you can then calculate how big it is based on its radius produced by the Schwarzschild radius calculation. And so in doing so, what we'll find is that no, black hole material is not all around, or compressed into a singular point in the middle, but our physics requires it to be there to calculate it well and calculate it easily. So we calculate gravitational force on something as if it's acting at the center of the object. So if you're calculating the force between the gravity of the Earth and the Moon, well, we calculate the gravity of the Earth as if we're at the very center of the Earth, and we calculate the gravity of the Moon as if we're at the very center of the Moon. And that center construct, the center of the object construct for figuring out gravity and stuff and forces, is what we're talking about. And that's how we talk about it with black holes. And we do that so that we can actually do calculations. If we couldn't, it would be monstrously difficult. We'd have to think of many other things. So it allows us to conveniently discuss gravitational fields, and knowing full well and having calculated that the gravity changes all over the planet. The gravity of the Earth is different in China than it is here. And it could be because of more density of rock here than there, or vice versa. And the way you understand this is if you go up in an airplane, right on your cell phones, you can actually get an application whose function it is to tell you the gravitational coefficient, the acceleration due to gravity where you're sitting in the plane. And on the ground, it's minus 9.8 meters per second squared. Okay? And you get up to 35,000 feet, and it's going to be less. That's going to be minus 9.6 meters per second squared up at that point, and higher. Eventually, it goes to zero. Once you get up into far enough reaches of space where you're no longer feeling the gravitational effects of the Earth and its mass. But gravity is infinite. You can always measure a force of gravity. Pluto feels Earth gravity. You can calculate it. It's very small, but you can calculate it. And vice versa. Pluto exerts a gravitational influence on the Earth, but it's very small. You can't really see it. Okay? And it's down in multiple significant figures in depth.
Can we zoom in a little more?
Yeah. We're getting to the point where we can.
Black eyes, now we're brown eye.
Yeah, that brown color is due to the actual color of that dust. Because this dust is actually brown, not black. Very cool. So if we drop it way down, you can see how that is a decidedly one-sided loop of brown dust.
And there's a bright edge. There was a bright edge just above that black eye. It's going all the way around the nucleus, but it's brighter on that side. If that's not just a contrast effect.
Yeah.
Looks kind of like an eye now.
It does. The Eye of Sauron? Not quite. Ronald asks, what are neutrinos and what effect do they have on planet Earth? Well, technically, neutrinos are a high-energy particle released during stellar nucleosynthesis. Um, at various stages along the way, you get neutrinos. And again, they are so they're fast. Okay, they travel at the speed of light, and they are a particle with no real mass, but they can be detected. They go through the Earth like it's not even there. So
They go through you like you're not even there.
that's true. They go through everything. Now,
Billions of them a second go through you every second.
well, in order to catch a neutrino, you have to have a giant underwater tank with water in it and thousands of detectors to detect that one chance collision between the water molecules and the neutrinos, and then those can detect the neutrinos. Interesting thing about neutrinos is that I mentioned this last time we talked. When neutrinos are made, just before a core collapse supernova, before the core collapses in a supernova to explode, during that rebound effect, there's a certain point at which neutrinos are made en masse, many of them. And out of 1 billion neutrinos, only one will get out. So there's many billions and trillions of billions of neutrinos that are being made at that time, but only 1 in 1 billion get out. But that's enough to signal the end of a star to us. So if we see a neutrino stream coming from, say, Betelgeuse, as I've mentioned before, then we'll know that Betelgeuse is about to go supernova. And it's only a matter of hours, because that's how long it'll take for that shock wave that's moving. It's material, it's matter that's moving outward from the center, and it's going to take hours, maybe 10, 20, 30 hours, depending on the size of the star, maybe even longer. But it'll take that long for the star's shock wave to reach the surface, and thus the star now knows it's going supernova, because you don't see anything. The star will look normal, but meanwhile there's a supernova underway deep inside. If you get neutrino streams in abundance coming from a star like that, just sudden burst of neutrinos, the star's about to go supernova. And our sun will never give you a burst of neutrinos because it's not massive enough to become a supernova.
Say that again. You kind of tailed off there. Our sun, what?
Our sun will never go supernova because it doesn't have the mass to go supernova.
Okay, but the sun does produce neutrinos.
Yes, for every part of stellar nucleosynthesis, we get neutrinos. But it's when we get that high energy stream of neutrinos right near the end when the core collapse is underway. It's actually the neutrinos which destroy the star. It's a whole other topic of conversation. But in a supernova, the neutrinos are what actually destroy the star. Because it's hard to stop them. But there's enough density inside that star that during that collapse where the neutrinos can actually kind of reach a wall. And as they burst through that wall, effectively, they will take the rest of the star with it. And that's part of why a star will explode. And but the neutrinos that are the precursors will have escaped the star. And when they get here, we'll know where we got to point our telescopes if we can see the neutrinos.
If Betelgeuse exploded, how would we know? If we detected neutrinos, how would we know they came from Betelgeuse?
It depends which way our Earth is facing and where the neutrino telescope is facing. We can detect, because it's a spherical tank, we might be able to detect the direction in which they came based on there might be a delay because the tanks are big. There'll be a subtle delay if it strikes the sensor near this one wall of the tank versus the other. We might actually be able to catch the delay like an interferometer does and see where the neutrinos came from, or at least get an idea.
Okay.
Yeah. Okay, we've done 24 of these. So I say we're done. Let's first bring back a little brightness here. Let's zoom out. Ah, yes. So all alone, sitting out there in space, it's the Black-Eye Galaxy. All the stars you see are way up here in the foreground in our galaxy. That galaxy is way out here, millions of light years beyond. Yeah, we're seeing it through the veil of stars. Well, I have a feeling that we're going to have some fun with galaxy season coming up.
Oh, yeah.
Without a doubt. Without a doubt, indeed. Well, I would say, guys, that this was a wonderful night. I want to thank you for coming out with us, hanging out with us, and enjoying our company. We've enjoyed your company very much. If you haven't subscribed, please do so. If you haven't joined our Patreon, please consider joining our Patreon. It's the way in which we can bring this to you. So please join our Patreon. You can find it right here at skytourlive.org, where you can pick any of several tiers, get finished images that have been finished down and processed in a way that's fantastic. We'll also be offering some of our products that we make, including things like this, which you can't see yet because I gotta make them better, right? Depending on the donors who want to do this stuff for us, you might get SkyTour Livestream sneakers. Look at that. SkyTour Livestream sneakers. And that's the Soul Nebula on the sneakers. These are in the Converse style. We have several styles. We have mouse pads. We have mugs. We have blankets. All kinds of things. And depending on the tier level you join with, you'll get a gift, and we're going to figure out what that's going to be. And we look forward to doing all these things for you because we want to keep bringing this to you. So please consider joining our Patreon, skytourlive.org. In the upper right, you'll see the Patreon ad or the Patreon link. On the upper left, you'll see SkyTour Livestream link here. And then scroll down, you get our beautiful server full of these pictures that we give you for free for these guys. So I hope you guys have a good evening, and thank you so much for joining us, and we'll see you again next time. Good night, everybody.
Good night, all.